ECEN 160 Lab 7 presentation by Brett Starks. This lab involved counters, more specifically up counters, ring counters, and gray code counters. Parts 1 to 3 involved creating an up counter. We started out with a simple transition table, showing what each output is expected to be on its next transition cycle. Afterwards, we converted the transition table into K-maps, leading to a simplified Boolean expression. This enabled us to make our circuit in Logisim. The trickiest part of this was using only NAND gates. I was finally able to get it to work with the expected amount of NAND gates by using one 3-input NAND gate and 6 2-input NAND gates. Parts 4 to 6 involved working with the ring counter. The steps were the same, save for using a different kind of counter, using don't cares in the transition table for outputs we didn't need to worry about. This required paying more attention to the transition table to formulate how to order each step in the circuit, but otherwise it was fairly straightforward. As you can see in the circuit, no additional gates were required aside from the D flip-flops. Part 7 to 9 involved some different thinking. This was a 2-bit gray code counter. As such, we only needed to worry about 2 outputs instead of 3. This counter also had an include, which needed to be enabled for the code to increment. If it was disabled, the output would not change. We were asked to create a hazard-free design, so it was necessary to overlap our min-term expressions. This ended up not being too much extra cost, as there was only one redundancy for each output. The final circuit directly translates the minimum Boolean expressions into the necessary gates to give the correct output. All in all, this was a fairly enjoyable lab. I felt like I got a bit better understanding of what is required for counters, as well as some valuable experience translating transition tables to Carnot maps to circuitry design. Thanks for watching.